A burning sun in a frozen sky. The sun is a massive ball of fire. Its surface burns at around 5500 degree, 9932 degree, and its core reaches over 15 million degree. It continuously emits energy in all directions. So naturally, you'd think the area around the sun, and even the space between it and Earth, must be blazing hot. But astronauts report that space is freezing, and in the absence of sunlight, temperatures can drop to nearly 270 degrees, just above absolute zero. Why does such intense heat fail to warm space? What is heat, really? To answer this, we must understand what heat actually is. In physics, heat is not a thing. It's an energy transfer. Specifically, it is the transfer of thermal energy from a hotter object to a cooler one. And temperature is the average kinetic energy of particles, how fast atoms or molecules are moving. So, no particles, no kinetic energy, no temperature, extreme cold. Heat travels in only three ways. There are three fundamental methods by which heat moves. Conduction. Heat moves through direct contact, like your hand touching a hot mug. Convection. Heat moves through a fluid, air, or liquid, like hot air rising. Radiation. Heat moves as electromagnetic waves, such as sunlight or infrared. Now ask, which of these work in space? Only radiation. There's no air or liquid in space, and no surfaces for conduction unless you're touching something. So space doesn't get heated like Earth does. Space. A vacuum. With nothing to heat, space is a near-perfect vacuum. There's no air, no gas, and almost no particles. It's this emptiness that makes space so cold. Even if radiation from the sun is flying through it, unless that energy hits something, it just keeps going. So the sun's heat passes through space without warming it, because there's nothing there to warm up. Radiation, the sun's only weapon in space. The sun sends energy into space as electromagnetic radiation, visible light, ultraviolet rays, infrared heat, X-rays, etc. Radiation doesn't need a medium. It can travel through the vacuum of space, but here's the key. Radiation doesn't heat space. It only heats objects that absorb it. When sunlight strikes your skin, a satellite, or a planet, those objects get hot, but the space between them remains unaffected. Why cold dominates in the shadows in space? Temperature depends entirely on whether or not an object is exposed to the sun. An astronaut in direct sunlight might experience temperatures over 120 degree, 248 degree. But if they move into the shadow of the spacecraft, their temperature could drop to 150 degree, 238 degree, or lower. There is no air to equalize temperatures, no breeze to cool or warm anything, only stark extremes between light and dark. Earth feels warm because of the atmosphere. On Earth, sunlight heats the ground, which then heats the air through conduction and convection. Our atmosphere acts as a giant thermal blanket. It absorbs solar energy, spreads it around, and traps it using greenhouse gases like CO2 and water vapor. This is why the sun feels warm on Earth, not just because of the radiation, but because the air around us holds and transfers the heat. In space, that whole system is missing. Space isn't cold because the sun is weak. It's because it's empty. Many people wrongly assume that the sun's heat becomes weaker as it spreads into space. That's true to an extent. The intensity decreases with distance. But even close to the sun, space is cold. The real reason is not the sun's weakness, but space's emptiness. Without air or particles to absorb and store heat, there's no way for the energy to turn into temperature. The role of matter. Only matter can be heated. Here's the key physics fact. Temperature is a property of matter. You can't heat nothing. You can heat a rock, a metal plate, a planet, because those things are made of atoms and molecules that can move and vibrate when they gain energy. Space is almost entirely free of matter, and without matter, there's no temperature. That's why even in bright sunlight, space itself stays near absolute zero. Final takeaway. The sun doesn't heat space, it heats what it touches. The sun is unimaginably hot, and its radiation is powerful. But space isn't a giant oven. It's a silent, dark vacuum where heat only exists when something absorbs it. So, space isn't cold because the sun isn't doing its job. It's cold because there's nothing in space to do the job with. It's not the absence of energy. It's the absence of things to receive and hold that energy.